So the best way to start learning about vectors is by learning about two-dimensional vectors. So let me write it down. Two-dimensional vectors. And a two-dimensional vector is just a pair of numbers written within a square bracket like so. So 2, 3, this is a vector. -1, -2, this is a vector. 3.5, 5.2, this is a vector. So in general, a two-dimensional vector can be represented as, u equal to x, y, such that both x and y belong to the real number set. And x and y are also known as the elements or the components of the vector. The order of elements within a vector is very important. So 2, 3 is not equal to 3, 2. For two vectors u equal to x1, y1 and v equal to x2, y2, if these two vectors have to be equal, x1 has to be equal to x2 and y1 has to be equal to y2. So these two conditions need to be simultaneously be true. So what we have seen is one way to represent vectors. You might also remember from your high school physics that vectors are something that have direction and magnitude. And in that sense, they are different from what are known as scalars. So scalars have just the magnitude. So, you can think of it like, let's say if you go for a walk, let's say you went for a walk today and you walked for 5 kilometers. So this thing has got no directionality associated with this, just a number. So this is a scalar. But if you say that you went for a walk today and you walked for 5 kilometers, and let's say you walked in a straight line from your home to your friend's home. So now you have a direction involved with 5 kilometers. So that quantity, 5 kilometers plus, let's say, the direction, 5 kilometer plus the direction, this thing will be a vector. And vectors are represented by an arrow in two-dimensional Cartesian plane. So let me draw a graph here. So this is the xy xy plane that we all know about, Cartesian xy plane. And let me draw a vector, u equal u. Let me draw a vector u such that u is ab, right? And let me choose any arbitrary point on the xy plane. So let this point be x0, y0. So if it's x0, y0, what it really means is that this point is x0 on the x-axis and y0 on the y-axis, right? And let me draw this vector like so. And the way I'll draw it, so this vector has to be drawn in such a fashion that the projection along the x-axis of this vector will be a, and the projection of this vector along this y-axis has to be b. All right. So there is nothing. Stopping you from drawing this vector from the origin itself. So you can draw the same vector starting from the origin, such that the only condition required is that the x-axis projection of this vector needs to be a and the y-axis projection of this vector needs to be b. And for two vectors to be equal in a graphical sense, the two vectors need to have the same direction and the same magnitude. So you can have a vector this, right? Let's say its length is L, and you can also have another vector which is like this, right? And let's say even its length is L, and let's say these two vectors have the same direction, then you would say that these two vectors are actually equal to each other. And this is not very difficult to see why, right? So let's say if these two vectors. So let's say this vector has a direction. So that means let's say its angle with respect to the x-axis is theta, right? So by using very standard common trigonometry, this length, right, this length would be L sine theta, right, and this length would be L cos theta. So you have the x and y projections of this plane, right? So then you can represent this vector as in this format too, right? Again, right? L cos theta and L sine theta. And we know that if two vectors uh, have their have equal x components, or have equal respective components, then those two vectors will be equal. So well, that's all actually I had to talk about in this lecture. In the next lecture, we will get to know more about vector operations.